Hey everyone, today we're going to be talking about matrix multiplication. So, matrix multiplication, right? It's taking basic regular multiplication and doing it with matrices. And the rules are a little bit weird, but we're going to talk through it, okay? So the first thing, the first rule and most important rule is that the inner dimensions must be equivalent. So like if your first matrix is X and it's an M by N matrix, and your second is matrix Y and it's an N by P, then you can do it because the second dimension of the first matrix and the first dimension of the second matrix are the same. And so your result, Z, which is X times Y, is going to be M by P. Okay? And the question is, well, how do we get each element of Z? All right, so Z, right, the ith row, the jth column, this looks super scary, right? But remember, summation notation, it's not that bad. All we have to do is look at what's going on, right? So the indices as k goes from 1 to n of xik, ykj. So the I is the same as in the Z, right? So it's that row, and then the J is that column, and this bears remarkable similarity to the dot product, because in fact it is the dot product. So the ijth element of Z is the dot product of row I of your first matrix and column J of your second. So what you're doing to get the ijth element of your new matrix, you do row I of the first and column J of the second. Okay? And I know this seems kind of weird, but let's look at some examples, and that's going to make things a little bit more clear. Right? So simple examples. Here, matrix C equals A times B. So we have matrix A and matrix B, right? So to get the first element of C, we go across the first row of matrix A and the first column of matrix B, and we do the dot product, right? So 1 times 5 is 5, plus 2 times 7, 5 plus 14 is 19. All right, now this one, this is the first row, the second column. So we again do the first row of matrix A and the second column of matrix B. So 1 times 6 plus 2 times 8. So that's 6 plus 16 is 22. All right? Then to get the third element of C, right, we have the second row and it's the first column. So we do the second row of A times the first column of B. So 3 times 5 plus 4 times 7. So 15 plus 28 gets us 43. And then lastly, we have the second row and the second column. So that's the second row of A times the second column of B. So 3 times 6 plus 4 times 8. So that's 18 plus 32, and that gets us to 50. All right, so that's how we do that. I'm going to let you try and figure out this one on your own, see if it makes sense. But it works the same way, right? The rows in F and the columns of G are how you get to H. So since F is 2 by 2 and G is 2 by 3, the inner dimensions are the same, so we can do it. And the outer dimensions, 2 by 3, gets us to the shape of H, which is 2 by 3. Okay? So those are some simple examples. And now let's look at some more complicated ones. All right? And you notice I don't have any numbers in these, but that's okay. These are just to help you understand what's going on. Right? So let's look at this one first. So we have a matrix A, which is a 3 by 2. And we've called this matrix D transpose. That doesn't matter. It's still just a matrix, right? And this is a 2 by 3. So if we want to do A times D transpose, we can, because it's 3 by 2 by 2 by 3. So the inner dimensions are the 2, and those are going to cancel, and we're going to be left with a 3 by 3 matrix. All right, and as you work through this, you can see this first element is the first row and the first column. So the first row of A times the first column of D transpose. Right? So alpha times mu plus beta times lambda. And you'll see that pattern going on over and over in this matrix. And that's kind of the reason why I like to use the Greek letters here, is because you can kind of see the symbols, how they transfer between the rows and the columns. So then the other thing I want to talk about is this matrix right here, B times C transpose. So if you remember from our vector multiplication video, right, we had two column vectors, B and C. So now what I'm doing, so the dot product, right, was B transpose times C. But now this is B times C transpose, a column times a row. And that's different, right? That's an n by 1 times a 1 by n. The inner dimensions are the same, so we're allowed to do it. We're allowed to do this multiplication, and it's actually going to be an n by n matrix, right? Where the first row is always going to be from the first row of B, which is just B1, right? And the first column is going to be the first column of C transpose, which is just C1. And so you can see this nice kind of block structure here, where each column has the C, each row has the B, and they're multiplied together. This right here is called the outer product. This is the outer product of vectors. Now you know if someone ever tells you what an outer product is. All right? So thank you guys for paying attention. Hopefully this makes sense. If not, I encourage you to go watch more videos of other people using matrix multiplication. Go try it for yourself. Work through it. Examples are the best way to get good at doing matrix multiplication. And we'll see you next time. Thanks for watching.